Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it. Hook. This one question lost more marks than any other on last year's papers. Students drew bars, they coloured them neatly, but they wrote down the wrong numbers, and that cost them the grade. If you thought the height of each bar was the frequency, you need to hear this episode. Sound familiar? I remember thinking taller means more and getting surprised marks back. Promise, in the next 10 minutes I'll teach you one concept, how histograms actually represent group data, one exam technique that wins marks every time, and one quick win to check your work in under a minute. Plus, we'll walk through a single worked example you can copy straight into your exam practice. The concept. Start with the simplest idea. A histogram shows how many items fall into each group, but when those groups are wider or narrower, the bars must change shape. Think of each bar as a rectangle. The area of that rectangle is what counts, not just how tall it looks. Say we have exam scores grouped like this, 0 to 5, 5 to 10, 10 to 20, and 20 to 30. Notice the first two groups are 5 marks wide, the next two are 10 marks wide. If you treat height as frequency, the wider groups would look wrong. They'd under or over-represent students. So we use frequency density divided by class width. So frequency density is the height we draw on the vertical axis.
Exactly. If a group has frequency 15 and width 10, its density is 15 divided by 10, which is 1.5. The bar's height is 1.5, its width is 10, and its area, 1.5 times 10, is 15, the original frequency. Area equals frequency. Let that sink in. Always label your axes. Horizontal axis, the class boundaries with units, e.g. score, marks. Vertical axis, frequency sensity, frequency per unit. If you forget the units on the vertical axis, examiners mark that down. Write it out. The examiner wants to see your method. Quick clarification. Do we use class boundaries or class midpoints on the axis? Good question. For a histogram, you always mark the class boundaries on the horizontal axis. Bars sit between the boundaries, touching each other. Midpoints are for frequency polygons, a different chart. Read the question twice, solve it once. The exam technique. Here's how marks are typically awarded on a histogram question. M1, you calculate frequency densities correctly. M1, you draw bars to the correct heights using a consistent scale. A1, you label axes, include units, and state any answers clearly, like estimated median. If you show your calculation for density, you can earn a method mark even if your final bar is slightly off. Common penalties are easy to avoid, not labeling axes, mixing up class width in the density calculation, or using bars that don't touch when they should. Write down your working. If you write density equals frequency divided by class width and calculate a number, that M1 is yours, even if you're drawing wobbles. Write it down, don't just think it. That makes sense, so method is gold even if the picture isn't perfect. The quick win, a 1-minute routine to catch almost every error. Step 1, calculate frequency densities for each class and write them next to your table. Step 2, choose a neat scale so the largest density fits on the page. Step 3, after drawing, do the area check. Compute area of each bar, height times width, and add them up. The total must equal the total frequency from the table. Takes under 60 seconds and catches most mistakes. Don't skip the check. What's a simple way to do that area check under exam pressure? Keep the densities beside the frequencies as you draw. Multiply each density by its class width. Note the products quickly on scrap paper, then add. If your total doesn't match the given total frequency, you know something's wrong and can fix it before time runs out. Worked example. Let's run a single example you can copy into practice. Our group data, 0 to 5, frequency 6, 5 to 10, frequency 9, 10 to 20, frequency 15, 20 to 30, frequency 10. Total frequency is 40. Step A, calculate densities. 0 to 5 has width 5, density 6 divided by 5 equals 1.2. 5 to 10, width 5, density 9 divided by 5 equals 1.8. 10 to 20, width 10, density 15 divided by 10 equals 1.5. 20 to 30, width 10, density 10 divided by 10 equals 1.0.
Write these numbers in a third column. So those are the heights I put on the vertical axis, right? Yes. Step B. Draw bars with those heights and the correct widths.
The first 2 bars are narrow, the last 2 are wider. Step C. Area check. Multiply each density by its class width to recover the frequencies. 1.2 times 5 equals 6. 1.8 times 5 equals 9. 1.5 times 10 equals 15. 1.0 times 10 equals 10. Add them. 6 plus 9 plus 15 plus 10 equals 40, the total frequency. If that matches your original total, you're good. Marks are there for the taking. Estimate the median from the histogram. Half the total frequency is 20. Cumulative frequencies before the 10 to 20 class are 6 plus 9 equals 15, so the median lies in the 10 to 20 group. Use linear interpolation across that class. Median equals lower boundary plus cumulative before divided by frequency in class times class width. Substitute numbers. 10 plus 20 minus 15 divided by 15 times 10 equals 10 plus 5 divided by 15 times 10 equals 10 plus 1/3 of 10 equals 13.33. That's your estimated median. This is a grade 9 move. Show the calculation. I like that. The numbers all link back to the original table, so it feels tidy. Final checks before you hand your paper in. Label both axes with units, show at least one density calculation in full, and perform the total area check. If the question asks for estimates, give the number to an appropriate degree of accuracy and state you used interpolation. Marks are given for clarity and method as much as for the final number. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find a free worksheet and a step-by-step PDF of this worked example at jcacademyonline.co.uk. Stay curious.